Hello, everyone. Today, I'd like to present an overview of the Biosystems Engineering program at Clemson University so that you can decide if this major might be right for you. My name is Kay Drapshow, and I'm an associate professor in Biosystems Engineering. One thing that we're really proud of in BE is the wide variety of sustainability and engineering activities that our students are involved in. So throughout this presentation, you're going to see photographs of current and past BE students and faculty working in the various areas that are encompassed with our program. And this even extends to the slide background. This slide is a photomicrograph of a local freshwater green algae called Starastrum. And this photograph was taken by BE students in a creative inquiry project called All About Algae. So the first question you may have is, what do biosystems engineers do? All engineers apply their engineering design and analysis skills to various systems. In our case, that means to biological systems. Biological systems are living organisms, cultures of microorganisms, wildlife, and even humans, and also the ecosystems in which those living entities reside. But we take it a step further. We also incorporate biological principles into our designs to preserve ecological balance. This is a pretty tough goal, but it's imperative to the sustainability and survivability of our planet. One thing we like to say about our work is if we do our job well, you may never even notice what we've done. And that's because our designs should blend into the natural system and be largely indistinguishable from it. Why do we need biosystems engineers? Well, I'm happy to say the photographs on this slide are not of BE activities. Mainly, they're of the pollution that is a result of our reliance on fossil fuels. So we need to develop alternatives to replace fossil fuels with sustainable and renewable options. We need to manufacture products using techniques that don't create toxic waste to begin with, or are highly efficient, so there's very little waste to deal with at the end. We need to develop communities using low impact design strategies so that the residential area doesn't interfere with or harm the natural environment. We need to restore systems that have already been damaged, and stream restoration is a really big part of our field. And we have to manage stormwater to minimize flooding, which has been exacerbated by erratic and increasingly severe weather events caused by global climate change. In other words, we want to make our world a more sustainable place. Our program, courses, and labs are housed in Brackett Hall. We are a small program. We have about 80 students in the sophomore to senior year. This means that you're not going to just be a number in a classroom. The faculty will know you and be able to help you succeed and meet your goals. Our curriculum is ABET accredited. It includes all of the basic engineering sciences, which builds that foundation as a strong engineer. We then add the required core life sciences of biology, micro, ecology, and organic chemistry. This gives you the knowledge to build those life science principles into your engineering design. And then, of course, our core courses incorporate both of the engineering sciences and the life sciences in the delivery of our content. Our students are highly successful in taking the Fundamentals of Engineering exam in their senior year and passing because of our strong curriculum. Our courses emphasize hands-on experiential learning, and this may mean conducting a land survey using the sophisticated tools and techniques that are used in the industry. It may mean implementing a design that you have created out into the natural environment, or testing different types of engineering systems, such as plug flow reactors. The two areas of focus in our program are ecological engineering and bioprocess engineering. Ecological engineering is based strongly in ecology and is focused mainly on protecting ecosystems, such as managing stormwater and restoring streams or other disturbed areas. Bioprocess engineering is focused mainly in microbiology, and the emphasis here is to produce in a sustainable way the materials, the biofuels, and the chemicals that we need in society to replace those fossil fuel alternatives. So, our senior design projects that students pursue reflect the diversity of topics that are within our field. For example, in the past, we've had students design a biohydrogen pilot plant using an 80-liter pilot scale sustainable reactor to produce hydrogen gas for use as a biofuel. Another team upscaled a garden shed into a fully sustainable structure using solar water heater, a solar air heater, a solar water still, and rooftop rainfall collection to water a vertical garden. We've had students focus on stream restoration of Honeycutt Creek, which passes through our campus. We've had other students focus on the biodiesel design process, and others focus on designing an irrigation system for the student organic farm. In the ecological engineering area, one project that we've had ongoing is to look at the global problem of oyster reef depletion. Roughly 80% of our natural oyster reefs have been destroyed due to overharvesting. This is really a big issue with our natural systems because oyster reefs provide a number of ecological benefits. They protect shorelines from erosion and actually encourage the accumulation of sediment behind the reef. They also provide habitat to a multitude of fish species. So restoring oyster reefs is really important. We found through our research that we can accelerate the establishment of oyster reefs simply by providing solid structures that the juvenile oyster can attach to. So, by placing these concrete or wire structures out into the natural environment, a reef can regrow in as little as 2 years. This is one example of where our design is indistinguishable from the natural system after just a short time period. Another example is in the design of bioretention ponds. In many malls, you might see a vegetative area in the parking lot, and you may think that that's just there for aesthetics. In many cases, this is actually a stormwater design which channels the runoff from the parking lot when it rains into a structure that collects that water. The microorganisms within the soil and sandy layers degrade the pollutants in the water and allows that water to recharge into the groundwater instead of flowing into a local stream causing flooding. In the bioprocess engineering area, we take the focus on the nutrients and microorganisms that are needed to produce a variety of biomaterials, biofuels, pharmaceutical compounds, and fermented foods. So the focus here is the right selection of the nutrient, microbe, and bioreactor environment to produce what we want. In the example of the biomaterials, the degradable plastics like PLA biopolymer is indistinguishable from a petroleum based plastic, yet it doesn't rely on fossil fuels and it will biodegrade. Some of the facilities that we have in our program include our mobile biodiesel unit, which has all of the unit operations needed to convert vegetable oils into biofuel in the form of biodiesel. So, as a student, you can be involved in operating and learning about this system through creative inquiry And you will also learn about it in your bioprocessing courses. We have other research facilities that have the highly instrumented bioreactors that are used in industry, and we conduct research on biofuels production, such as hydrogen and ethanol. Other research facilities that we have are our algae culture units, which we've called our carbon capture center, because they can be used to capture atmospheric carbon dioxide and sequester it in the algae biomass to address global climate change. Our students have many opportunities upon graduation with a BS degree in our field. We encourage our students to either co-op or intern, and many do. Roughly 70% of our students directly enter the workforce right after graduation in jobs dealing with ecological engineering, bioprocess engineering, or sustainability engineering. The other 30% go on to highly ranked graduate programs. The job successes that our students have achieved with a BS degree are shown here on this slide, which just lists some of the companies that our students get employed by. The names in bold are companies that have hired many of our students. And these jobs, again, are within the ecological engineering, bioprocess engineering, basic engineering, and also sustainability. One question that students often have is, how is biosystems different than environmental engineering? You can see from this diagram there is overlap within the two programs in the focus on sustainability and biological waste treatment. However, our program, which emphasizes bioprocess engineering and ecological engineering, differs greatly from the topics addressed in environmental engineering. Both programs are great and both work synergistically to make our world more sustainable. Our students are highly involved through the Biosystems Engineering Student Club, which is a branch of our professional society, the American Society of Agricultural and Biological Engineers. Our students are really focused on being a part of a generation that will change the world. If you have questions about our program, please reach out to us. You can email me, Kay Drapshow, or our undergraduate coordinator, Dr. Tom Owino. We hope you've enjoyed this presentation, and thank you for your time.